All right, hello everyone. Today we're going to look at what's called probabilities of mutually exclusive events. Okay, mutually exclusive is something that happens when you're looking at two different events. Okay, so you're going to see the word or. Now, mutually exclusive specifically means that things do not overlap, or there's no union. Okay, so they don't have anything in common. If they are not mutually exclusive, they have something in common with their sample space. Now, I'm going to hopefully go through some examples and make a little more sense for this. But the big question you just have to ask yourself is, do these two items, whatever it happens to be, have anything in common that overlaps? Okay, so here's what we're going to be looking at. It says determine if the events are mutually exclusive or not. So here's the first one. So the first one says you have a junior winning the election or a senior winning the election. Now, if you think about this, juniors and seniors, they're two different grades. They don't have anything in common. Okay, so there is no overlap there. If you have a junior win an election or a senior win an election, they can't be the same person. So these would be what we call mutually exclusive because they are separate. Now, the second example here says a sophomore winning the election or a female winning the election. Now, if you really think about what this is telling you, you have a sophomore that wins the election or a female. Well, the question you have to ask is, can you have a female that is a sophomore? And the likelihood is, yeah, there are females that are sophomores. And so since you have the same type of person in both groups, they are not mutually exclusive. Okay, so that's what you're looking at, is trying to determine if there's any sort of overlap on these categories. All right, so the next one. You are drawing a spade or an ace from a standard deck of cards. So if you look at all these spades and you look at all the aces, are there any cards that would fit into both categories? Well, yeah, there's aces of spades, so in this case, it's not mutually exclusive. Okay. And then finally, if you draw a 7 or a face card, are those mutually exclusive? Sevens are not considered face cards, so there is no overlap, so they are mutually exclusive. All right, so that's the whole idea behind this. Hopefully that made a little sense. If you still are having trouble with that, and you still are after the video, definitely contact me and we can go through them together. Now, there's a couple formulas that you're going to want to be able to use, and they're essentially the same thing. It's just an extension of one. If two events are mutually exclusive, the probability is the sum of their individual probabilities. Okay, so if I say, I want to know what's the probability of this or that. Well, what you've got to be able to do is figure out each of those probabilities and then add them together. And that's the key. With the word or, you're going to add. Okay, so find each probability and then add them. So here we go. From the following table representing the song on your playlist, what's the probability the first song played, sorry, another one of these typos, so song, first song played is from album 1 or 4? Alright, so here's how we start this. We need to know what's the probability first of the song being from album 1. Well, just like any other probability, you do the items that you want over the items that you don't want. So you've got 12 songs that you do want over the 40 total songs in your playlist. Now, because we're adding and we're dealing with fractions, I would say hold off to simplify just to make sure that you already have a common denominator. So the next one is, what's the probability that the song is from album 4? Well, there's 6 songs that could happen out of the 40 possible, so it's 6 out of 40. And now, since these are mutually exclusive, those songs don't overlap, we can take 12 over 40 plus 6 over 40, which gives us 18 over 40. All right, and so we add those together, you get that 18 over 40. And then finally, you're going to reduce that down. 2 goes into each of them, so you end up with 9 over 20. And there's the probability that that first song is from album 1 or 4. Okay, next example. You reach into your purse and you have 30 quarters, 25 dimes, 40 nickels, and 15 pennies. Okay, so you got a bunch of change in there. you want to know what's the probability that the first coin you choose is either a quarter or a penny. All right, so you're rummaging around in there. You pull out a coin. What's the probability it's a quarter? Well, there's 30 quarters out of how many coins? Well, we add 30, 25, 40, 15. You get 110 coins. So 30 out of 110, that's the probability that you get a quarter. To that, you're going to add the probability you get a penny. Well, there's only 15 pennies, but there's still those 110 coins in there. Okay, so we add these two things together. We end up with 45 over 110. And that is your probability. Now, what we've got to do here is simplify that down. Okay, so we look at this. You see that maybe 5 goes into each. So that works out to be 9 out of 20. And there's your probability. All right, hopefully that makes some sense as to what you're looking at. Now, the final part of this is what happens if there is an overlap. Okay, if there's certain things that occur in both of these different sample spaces. Well, we've got a different formula. So you can see there it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And this right here is your overlap. All right, so you're going to add them together just like before, and then you're going to subtract that overlap. So here you go. Find the probability of pulling a red or a king from a standard deck of cards. Okay, so we want to know probability of a red. Well, there's 13 reds out of 52 cards. Then we go probability of a king. Well, there's 4 kings out of the 52 cards. Now, ask yourself, is there an overlap? So basically, is there a red king? And the answer is yes. There are 2 red kings. So we have to take away those 2 red kings because they occur here and they occur here. We can't count them twice. So now you simplify this. You got 13 plus 4, which is 17, minus 2, which is 15. So that gives you 15 over 52. That is not something that reduces down. So there's your final answer, 15 out of 52, and you're done. All right, final one. I want you guys to try this one out on your own. Pause the video, come back in just a second. Okay, so you select a number from 1 to 20. What's the probability of getting an even number or a number that's divisible by 3? All right, so let's start with the even. From the numbers 1 to 20, how many even numbers are there? Well, it's every 2 numbers, so there's 10. So 10 out of 20 are considered even. Then the second part of this is how many of them are divisible by 3? Well, we still have 20 numbers, and the ones that are divisible by 3 are 3, 6, 9, 12, 15, 18. So 6 of those numbers are divisible by 3. Now, are there any of those that are divisible by 3 that are even? Those are our overlaps. Well, you've got 6, you've got 12, you've got 18. So there's 3 of those 20 that happened in each of those sets. And we can't have them both. So we simplify down. So you end up with 10 plus 6 is 16, minus 3 is the 13. Your denominator is still 20. 13 over 20 does not reduce down. So that is your final answer. All right. Hopefully that helps out. Made some sense. If you have any questions, definitely contact me. Let me know. Otherwise, good luck.